Okay, let's start. This hacking session is about enable deepest power state for suspend to idle. Since I think I don't much to share, so I will have a short self-introduction first to take my time, okay? I'm from Unisoc, which was known as Spectrum, and our company is focused on mobile phone SoC design. After I joined this Spectrum, I was assigned to Linaro, working in kernel working group, and started switching to power working group just a few months ago. Recently, I have been looking at suspend to idle things. The goal is like those two pictures show, compared to two kinds of suspend, when we can see if system enters into suspend to run, it can save more power than it enters into suspend to idle. The left is for the current situation. We hope suspend to idle can reach the same power consumption as suspend to run in the future, like the right picture shows. This is the environment I have been doing this task. I use Unisoc's mobile phone, and the SoC has 8 cores of Cortex A55 in 2 clusters. I use mainline kernel, but with few necessary module drivers. The firmware on that supports PSI 1.0. The power topology is showed on the picture of right side. We can power off each core respectively, and the 2 clusters as well. Also, the top the top part domain, this part. Yeah, right. I started from looking at 2 suspend activities in PSCI space. The purpose was to make suspend to idle and suspend to run having the same activity in PSCI. Suspend to idle and the suspend to run would call a same function in the first line at the end, but parameters were not same if using the property configured in the device tree previously. And we can see they have different target power level. For suspend to idle, the target level was 0. And let's see how to make them having the same parameters. And I found there's a property in idle state which can be configured in directory. We can just cite this parameter to make to let suspend to run and suspend to idle have same parameter when call this function. And in the following, I will call this kind of C state with deepest C state. Okay. Actually, I just added a new C state with revising this property to, yeah, just like I show here.
The deepest state will be used by the idle governor. For example, on the runtime, the CPU idle governor can select the deepest idle state, and so can dynamically run into this idle state and exit, not use the S2I.
Yeah. Since this deepest state can be used at runtime, yeah. If we don't do anything further.
But the question is that if we use the deepest idle state for the CPU idle, this is dependent on all the device power on and power off, right?
Yeah.
So how you constrain for the device? Because that CPU idle, this is the master from CPU side. He wanted to enter into the deepest idle state. But all the device maybe is on or off, but you need depend on this device state. So how do you handle this?
So initially the goal is to use the cluster idling. If you have the topology described with all the port domain, so at the end you should have this large and system level port domain. And using cluster idling, you can take into account the state of all the device, not only the CPU. So you should not enter this state until there is a device running. So if you have one device, I mean, which means that at runtime, because all the devices are used, you should never enter that at runtime. But when you are entering suspend to idle, all the devices will start to suspend. So at the end, at the system large power level, all the devices will be suspended, all the CPUs will start to be suspended as well, and then cluster idling can say, I can pour down this system level domain, which means entering this PSCI state. Okay. That's the theory. Then we've seen that there is some restriction for now with cluster idling. And Chunyan is using the coordinated mode and not the OS initiated mode. Okay. And in this case, you can use the CPU DMA QoS latency to say that I want to wake up at runtime, I want to wake up with this kind of millisecond. And if your wake up constraint is shorter than the wake up latency of this state, you will never use that at runtime. But in suspend to idle, you don't take into account this PMQoS latency. So you will select it.
Okay. So the constraint use the latency to do the constraint. Okay. Okay.
Yeah. You know, previously I didn't set any constraints for the governor. It indeed would enter into the deepest C state.
And that also means that if we want to look even further, because now you have this system-wide C state where you can put the DDR in self-refresh. And the main constraint is that making sure that no device will try to access that. So if we have enough, if the topology, port domain topology description is fine enough, is fine-grained enough in Linux, at runtime, you can be in situation where all the devices are idle, and typically nothing prevents you to enter this state at runtime and put your DDR in self-refresh if you know that you will not use that for 1 second or something like that. But we are not yet at this level. Sorry? No, it's not done yet. Because this means that you must be sure that all the devices are described in your Linux system, and you are sure that no device will try to use the DDR.
So the infrastructure code is already on the mailing list to do this kind of stuff? So the infrastructure code to do this kind of stuff is already on the mailing lists. So that's the cluster idling series I talked about before. And there was a few limitations there. For example, supporting these several levels of hierarchy that needs to be addressed and fixed to make this work. But the principles is there, and the overall design is there already to do this.
Okay. I made a few tests on below scenarios. We can see with the deepest system I just mentioned, if I leave one core only alive, we can reach, we can see suspend to idle can reach the similar power consumption with suspend to rhyme. But apart from this case, other cases, suspend to idle cannot reach the same power consumption with suspend to rhyme. Actually, I found when suspend to rhyme, PICI CPU off will be called, and that means the secondary cores would be unplugged during suspend to rhyme, and that's also be confirmed by talking with Wolf on this Monday. Yeah, and that's also explain that why we can see on this scenario. On this scenario, we can see suspend to idle can reach the same power consumption with suspend to rhyme, since we have power off or unplugged our secondary CPU cores. But even with leave only core alive, if we didn't add C-state with the parameter I just mentioned, we suspend to idle cannot reach the same power consumption with suspend to rhyme. I also tried to switch to GMPD, but the result of tests for those scenarios are now changed. Yeah, like you said, 3 levels of GMPD are not supported for now. Okay. I looked from the registers to see about DDR self-refresh, if DDR self-refresh is set, and the DDR device is set auto self-refresh. We call it auto self-refresh for both suspend, but that should be only granular self-refresh, not not setting DDR controller to self-refresh. Looking from the register's value, we probably can confirm the DDR controller seems not in sleep state for both suspend. Heard from my colleague who are in charge of power management and low power stuff. They told me that maybe some components on my board hasn't been put into deep sleep yet, since there are many components such as communication processor, GPU, various modules on my board. So maybe there are still some components didn't enter into deep sleep. So DDR cannot be set self-refresh for this reason, I think. I think next I will continue to find out which parts of components or processors didn't enter into deep sleep, and also need to look at this function. I think that maybe need to look at the registers using some trace debug tools. Yeah, that's all. Any suggestions?
I think you're right that you have to look in your current implementation. So you have the function for the last CPU that will enter the state, but you miss some configuration for the other CPU, and that's probably what you will have to look at the CPU of what is done there that can be used, and so that you will be able to reach the lowest value even with all the CPU and all the cluster. That should be possible.
Okay.
Which means that you should be able to get the power consumption level of suspend to RAM with suspend to idle. I mean, once you will have done that, you will have the same you will have the same sequence, the same configuration, so you will have the same power level. Then, if you have any additional things that you need to do to put your DDR in self-refresh instead of auto self-refresh, if this works for suspend to RAM, this should work also for suspend to idle.
Yeah.
In this case.
Yeah. I before I come to Connect, I have been looking at suspend to RAM. When system enter into suspend to RAM, what's the register's value are?
Yeah.
Yeah, right. For now, during suspend to RAM, DDR didn't set self-refresh still.
I just want to remind that for suspend to RAM and for suspend to idle, maybe they have difference for the wake up source setting. I'm not sure. Just
Yeah.
sometimes maybe for suspend to RAM you have set some wake up setting, so it can run into. I'm not sure they have some difference, and
There should not be difference because usually it's coming from its part. We should not have that much difference because the suspend sequence of all the devices is exactly the same, and we are configuring the wake up source during the device suspend call, and not during the CPU, the last part, which is the CPU part. So we should not have any difference at this level.
Sometimes the difference is that the wake up source, for example, suspend to RAM, the wake up source is not usually the gate or interrupt.
Oh, you mean
controller.
which source can wake up the system?
Yeah.
Okay.
So maybe these two different power state maybe have different configuration. So I'm just so question that how software to handle this difference, right? Another thing that how you hardware to set this setting for suspend to idle state.
But even for that, to be honest, I'm not 100% sure, but I think it's the same because from it's system suspend and suspend to idle or suspend to RAM, usually the same event should wake up you. So there is a,
Okay.
I mean, when you call when you select suspend to RAM or suspend to idle, it's
Should
only the power level.
Okay,
that
okay.
doesn't, it doesn't have any link to which wake-up source you will be able to use or not. I'm not fully sure of that. I agree with you that we have to check, but
Another thing that for suspend to idle, since that all the CPUs not being hot plug off, how to control which CPU is last man and which CPU is the first man?
the PSCI is in charge of that. It's in PSCI, in the coordinated mode, they are looking at the last man,
Yeah.
the last CPU.
Yeah.
They already do that for cluster, so it's exactly the same mechanism. You just have another level. So normally they are only the last CPU will call this special function. But you have to call some other things for the other CPU.
Okay, so that means that for suspend to RAM, the power controller just only to know to handle the case that the CPU 0 is the last man and the first
Yeah.
man. But for the CPU idle, to suspend to idle, the power controller needs to handle every CPU is possible.
Yes, that the main difference is that typically, in suspend to idle, CPU 2 can be the last CPU, whereas with suspend to RAM, it's always CPU 0. But I'm not sure that makes a difference at the end.
Sometimes maybe the power controller have some limitation.
Oh, you mean, yeah. Yeah, maybe, yeah. Sorry?
Do you think it's going to be useful to force CPU 0 to be the last man in that case?
Yeah, I think so. Because that
I'm not
experience-
so. In some way, yes. The point is that I think that in suspend to idle, so what in the configuration that is using Chunyan, only when all the CPU are asking for this new deepest state, only the last one will do something. All the other one will stay at the cluster off level, will prepare CPU off level even that. And they are missing some, they are probably not disabling some controller, some currency stuff. And that's why we are not able to reach the deeper state, because the currency stay on, something like that.
It's a bug in the firmware. In PSCI.
Not in PSCI, it's platform specific. It's just that we forgot to call some function. In your PSCI firmware, you are describing, you have some platform specific function to be called when you want to put CPU off, and then when you want to put cluster off, and then when you want to put in DDR self-refresh. But in this case, you have a function that have to be called by the last CPU. But as far as I can tell, Chunyan haven't done anything for the other CPU, whereas in this case, we have to do something. Even if you're not the last one, you have to do something to be prepared. You see the point? And I think that's what is missing right now. When you're on, even for the cluster off right now, when the CPU wants to be cluster off, you have to be prepared to be cluster off. And if you're the last one, you're doing something, an additional things to put the cluster off. In this state, it's the same. I mean, if you want to be, you must be prepared to be in self-refresh mode. And only the last CPU will try to enter the self-refresh mode. Yeah. But I think that we miss the preparation of the other CPU.
Or because of using more than one CPU, there is something which is power on, we don't power off. So in the last line, just the last test. You have all the cores and you unplug all the cores until you have one, or you just boot.
I have tried both. Yeah, I have tried remove cores from device tree, only leave one core out. Yeah, only leave one core. And I also tried bring up with 8 cores and then unplugged the core 1 to the core 7, only leave core 0.
Okay, it's when you have the scenario
Yeah.
with the last line, only one core alive.
Yeah.
How did you have one core alive? Well, because in the DT, or you unplug the other one, or the other CPUs.
Both cases.
Yeah.
So it's the both case.
Yeah.
So in both case,
Yeah.
we have.
Did you try out having different CPUs as being the last man? Was it always CPU 0 as the last man?
Didn't.
But could we not test it if we try?
Yeah.
Just to see if the firmware is doing some special things.
Yeah. Yeah. Okay,
You're
I will
right.
try.
That could be a good test to do, to plug everything except CPU 2. Because now normally, yeah, you can even unplug the booting CPU now. So yeah, that can be an interesting test.
Okay.
Have you, one interest of using suspend to idle compared to suspend to RAM is the resume time, which should be shorter. Have you done some measurement? Have you seen any difference? The fact that you don't have to, for the case where you have all the core, have you seen some difference in the resume time?
You know, there are few things running on my mobile phone, so I could not see the difference. Yeah. Any questions or suggestions? And if no, I think we are here. Okay? Yeah, thanks for coming.